Welcome to This Explainer. Okay, I want you to completely forget about those 18th century European laboratories filled with bubbling glass flasks. Just for a minute. Today, we're rewinding the clock back millennia. We're going to look at the evolution of chemistry through a totally different lens, specifically through the eyes of an ancient Indian historian. We're journeying way back to uncover the lost chronicles of early chemical sciences and see exactly how ancient civilizations understood the fundamental building blocks of our world. So that brings us to a pretty provocative question. When was chemistry actually invented? Now, you know the standard textbook version, right? It tells us modern chemistry was born in Europe just a few hundred years ago. But if we shift our gaze over to the sands of the Indus Valley, to incredible archaeological sites like Mohenjo-Daro in Sindh and Harappa in Punjab, we find out the story of chemistry is, well, it's incredibly old. Systematic excavations there have proved that highly sophisticated chemical processes were happening literally thousands of years before the so-called birth of modern science. You see, if we look at it from the perspective of our ancient Indian historian, they wouldn't even recognize chemistry as some rigid, isolated subject. Instead, what they practiced was called Rasayan shastra. This was a vast, fully integrated discipline that seamlessly blended things together: metallurgy, medicine, the making of cosmetics, glass, and even dyes. To them, chemistry wasn't about memorizing abstract equations on a chalkboard. It was the practical, hands-on manipulation of matter, all designed to basically improve everyday life, health, and society as a whole. And the sheer scale of their chemical mastery, it's honestly staggering. We aren't just talking about basic campfires here. The mass production of baked bricks in Harappa, for instance, required this precise mixing of materials and highly controlled heat. I mean, it's arguably humanity's very first industrial chemistry. They were hardening copper by adding tin and arsenic, crafting these really delicate glass ornaments, and even tanning leather and dyeing cotton way back around 1000 BCE. But here's the absolute kicker. In northern India, they forged the specific type of black polished ware. It had this golden gloss that shows such an insane, masterful control of kiln temperatures. Get this, its exact chemical replication still baffles our modern materials scientists today. Crazy, right? But I think the true marvel really lies in ancient texts like the Charaka Samhita, which is the oldest Ayurvedic epic of India. It meticulously describes using metal bhasmas to treat different ailments. Now, really think about this for a second. Modern scientific analysis has actually stepped in and proven that these ancient bhasmas literally contain metal nanoparticles. Yeah, millennia before modern science ever coined the buzzword nanotechnology, these ancient practitioners were already harnessing the extreme reduction of particle size to heal the human body. It is just an absolute wow moment when you realize they were actively practicing nanomedicine long before we even invented microscopes that could see it. It is just an absolute wow moment when you realize they were actively practicing nanomedicine long before we even invented microscopes that could see it. And man, this brings us to such an incredible historical irony. We're all taught John Dalton's 1808 atomic theory as gospel, right? The whole idea that matter consists of indivisible atoms. He gets all the textbook glory. But roughly 2,500 years before Dalton ever stepped foot in a lab, a brilliant Indian thinker named Acharya Kanana conceptualized something called Padmanu. He described them as these eternal, indestructible, spherical particles that pair together through unseen forces. So the fundamental blueprint of the atom, it wasn't actually born in industrial Europe. It was reasoned out as a really well-defined philosophical truth way back in 600 BCE in India. Okay, so how exactly did we bridge the gap from ancient Paramanu to the super rigorous chemistry labs of today? Well, it definitely wasn't a straight line. While alchemy and medical chemistry absolutely flourished in India right through the 1300s, those traditional techniques eventually began to kind of stagnate around 1600 CE. Meanwhile, halfway across the globe in 18th century Europe, scientists were busy building a new, rigid framework for modern chemistry. Eventually, by the mid-19th century, European scientists started coming over to India, bringing this empirical system with them, and that gradually ended up replacing the older indigenous traditions. This transition was completely revolutionary. I mean, imagine our ancient historian looking at the 18th century. Their brilliant, intuitive, philosophical speculations were finally being quantified into universal mathematical laws. When figures like Antoine Lavoisier proved the law of conservation of mass in 1789, he basically proved with exact measurements what the ancients had felt intuitively all along, that matter can't ever be created or destroyed. The ancient ideas weren't wrong at all, actually. They were just finally being anchored by rigorous, irrefutable numbers. The proof of this new empirical era is just elegantly simple, and it's perfectly demonstrated by Joseph Proust's famous Copric carbonate experiment. Proust took and tested two samples. One was naturally occurring, and the other was synthesized in a lab. And the results are just a beautiful revelation. Whether it was natural or synthetic, the elemental breakdown was absolutely identical. Exactly 51.35% copper, 9.74% carbon, and 38.91% oxygen. Boom. Through this super simple data, Proust proved the law of definite proportions. Nature, as it turns out, follows these strict, unchanging mathematical recipes regardless of where the ingredients actually come from. All of this exact measurement ultimately culminated in stoichiometry, which is the highly specific calculation of masses and volumes in a chemical reaction. Just think about the incredible legacy here. We go from our ancient historian mixing exact amounts of clay and heat to forge a durable brick in Harappa, all the way to the precise mathematical balancing of the universe's matter today. It is literally the exact same human drive to systematize knowledge and understand nature, just viewed through an increasingly sharper, mathematically grounded lens. Which really leaves us with a pretty humbling thought, doesn't it? If ancient practitioners in India could grasp the core foundations of nanotechnology and atomic theory millennia before the microscope was even invented, what fundamental chemical truths might we be completely overlooking today? As we look back at the brilliant intuition of the ancients, what in the world are future historians going to marvel at when they look back at our modern science? Let that sink in. Keep that curiosity alive, stay focused, and hey, thanks for joining me on this explainer.